In this video, we're going to look at what's called unions and intersections. Now, that's just a fancy word for saying events that can maybe happen at the same time, or maybe events that don't happen at the same time. Let's think about rolling a dice. So we know that the sample space of a regular dice is 1, 2, 3, 4, 5, and 6. They're all the possible outcomes. Now let's think about, well, what about all of the even outcomes? So they are 2, 4, and 6. Now we also have odd numbers in this set, so that's 1, 3, and 5. So we can represent these on a Venn diagram. And the way that we do this is we draw ourselves a little picture like this. So one big rectangle, and everything inside this rectangle has to be included in this sample space. So we can't skip any numbers. And then we have two circles. The first circle here, let's say that this circle represents even outcomes, and the second circle represents odd outcomes. So there's two ways that we can do this. We can either list all of the possibilities individually. So for example, the even outcomes, well, there's a 2, a 4, and a 6. And then for the odd outcomes, there is a 1, a 3, and a 5. There are no outcomes in the middle because you can't have a number that's odd and even. And there are no numbers on the outside because all of the numbers have to fit into either of these two categories. Now, another way of writing it, instead of listing the numbers, you might just say how many outcomes there are. So we would say here there are 3 even numbers and 3 odd numbers. There are 0 numbers that are both. You can't have a number that's even and odd. And then there are 0 numbers that don't fit into any of these categories. So basically, that's how a Venn diagram works. Let's have a look at another example. So here is an overview of how Venn diagrams and then set notation sort of come together to describe different events. So the intersection of A and B, or A intersection B, is shown by this crossover part of the Venn diagram in the middle. So A union B, or sometimes you can say it out loud as A or B, represents when A or B events could happen, either one of the two, and that's shown by shading in both of those circles in the Venn diagram. Now we can talk about when event A doesn't happen. So we can call this not A, or the complement of A, and that just means it's every single space of the Venn diagram except for the A circle. So that means all of this zone, but also all of the outside. So this is not A, or the complement of A. It's everything except for event A. So similarly, we can say not A and not B. So everything other than events A and B. So we can't shade either of those circles. We can't shade the A circle that represents event A or the B circle that represents event B. So that just means all that's left really is the outside. So this is not A and not B, or not A nor B. And of course, we can talk about event A happening. So that's the whole of this circle, and it also includes the intersection because that does count as event A. And then we can also have event B, so which is the whole of the B circle, including that intersection part, because that also includes event B as well. Let's have a look at numbers in this set that are multiples of 3. So the multiples of 3 are 3 and 6. And let's also have a look at even numbers. So we've got 2, 4, and 6. So let's fill out a Venn diagram to represent this situation. So multiples of 3, we have 3 and 6. Now even numbers, we have 2, 4, and 6. And you'll notice that one of these numbers doubles up. We're not allowed to write any number in twice. So this number here really should go in this middle section instead, because 6, is both a multiple of 3 and it's also an even number. So that's why it lives in this middle zone, this intersection because it fits both categories. Now, there are some numbers that don't fit either of these two sets. So numbers that aren't included in here or in here. Those numbers are 1 and 5. So the outside space represents numbers that don't fit into any of these categories. So a bit of vocabulary for us. The first word we're going to talk about is intersection, and I mentioned this one before. Now the word intersection just means a part of this story where both situations or both conditions are met. So this part in here is what we call the intersection because it's the crossover between both events. It's where even and multiples of 3 occur. The other word we're going to have a look at is the word union. So this just means a section of this Venn diagram where one event or another can occur. So this is actually both circles here. So let's have a look at these two words in an example. So here's another situation, and this time we've got event A and event B. So event A, there are 5 possible outcomes that fit event A. 4 here and 1 here, but they're both inside this entire circle. So we say in total there are 5 outcomes that fit event A. In total there are 4 outcomes that fit event B. So there's 1 here, there's 3 here, and another 1 here to make 4. And then there are 2 outcomes that don't meet either of those, so they're on the outside. Let's have a look at a couple of examples using our notation that we use when we describe probability. So the probability of event A happening. So the total number of outcomes all up, if we add all of these numbers, there are 10. But the ones that we're interested in, so anything that meets the condition of being event A, well, there are 5 of them. So we can simplify that fraction to 1 over 2. What about the probability that event B happens? Well, there are 10 total outcomes, all up, and 4 of them happen inside the B circle of the Venn diagram, so 4 of them are part of event B. What about if we said the probability of A or B, it doesn't matter which one as long as it's one or the other, so there are 10 in total, but how many of those outcomes are either A or B outcomes? Well, we've got 4, 5, and another 3 is 8. So that's 8 out of 10, which we can simplify to 4 out of 5. Now, we mentioned the word union before. Another way of writing this is A or B. So that symbol there is just the union symbol. So that's the special probability symbol that we use. So they both mean the same thing, 8 out of 10, 4 out of 5. So if we were to draw on our Venn diagram the region that represents A union B or A or B, it's the whole of this circle and the whole of this circle here. So A or B. So it's this red zone. This time let's have a look at the probability that event A and event B both happen at the same time. So they both must happen at the same time. So in total we have 10 outcomes, but there's only one situation, there's only one outcome that is both A and B at the same time. So it's 1 out of 10. Now the special way that we write this in probability using our special probability symbols is this. So this symbol here is the intersection symbol. And if we were to shade the region that represents A intersection B or A and B, that's this middle part in here. What if we wanted to find the probability that event A happened but not B? So what we would need to look at is, well, what are our total number of outcomes? There are 10. And how many of these outcomes meet the condition of being event A but not B? I'm going to shade this one first so we can see it straight away. So this is A but not B. But we can't shade in that other smaller section because that part includes event B. So A and not B is shown by this section here. Now there are 4 outcomes in that zone, so this event is 4 out of 10, and we can simplify this one to 2 out of 5. There's a special way that we write this in our probability notation is A and not B, so we use B dash to say not B. Now we can also say what is the probability of not event B not happening. So that's everything except for that B circle. So if I was to shade this one in maybe a different color, I'm going to do green this time. So everything except for event B. So that's out here. Ooh. So that's not B. This part is also not B, but I can't shade in the circle that represents B. So let's have a look at how many events meet this condition. So there are a total of 10 events. So we've got 2, 4, so we've got 6 out of 10. So the probability of event B not happening or not B is 6 out of 10. We can simplify this to 3 out of 5.